Okay, so we're going to look at the second lesson today on series and sequences, and we're going to look at arithmetic series. Now, at the last lesson I said there is a difference between the words sequence and series, and this is what it is. An arithmetic sequence is just a list of numbers that have a common difference. So it would look like this. It would look like 3, 5, 7, 9, 11, and so on. And that would be a sequence of numbers. So it's just a list of numbers. An arithmetic series is when you take that sequence of numbers and you add them together, and then it's called a series. Okay, so we could have a series that looks like that. We could have a series that's 101, add 99, add 97, add 95. And so it's exactly the same, but we're adding the terms together. And we need to be able to derive a formula for working out what the sum of a series is. But before we do that, I'm going to do something that you might have done when you were in your GCSE years or even in year 9 or 8. And it's something that we sometimes give pupils, and we say find the sum of the numbers from 1 to 100. So what's 1, add 2, add 3, add 4, all the way up to add 100. And a few of you might have in the past said, well, the best way to do that is actually to link the pairs together. Because what you notice is if you do 1 add 100, you get 101. 2 add 99, you get 101. 3 add 98, you get 101. So in a way, if I wrote my series backwards, like this, plus 97 plus and I'm going to have plus 3 plus 2 plus 1. If I added these two series together, then each of these pairs is going to make 101. So I'd have 101 plus 101 plus 101 all the way up to plus 101 plus 101 plus 101. But I've got two of my sums now. Effectively, I've worked out the total of two of my sums. So I say two of my series added together is 100 times 101 because we've got 100 terms. So effectively, my series is 50 times 101, and that gave us 5,050. And it was a neat way of working out the sum of a series. Well, we can use that to actually create a formula for ourselves. So if we consider the series, we've got A as our first term, plus, well, what would the second term of this series be? Well, it'd be A plus D. The third term would be A plus 2D, and so on. And I'm going to use the letter L to denote the last term. Okay, just to make it a bit easier. Well, what would this term be? What would the second to last term be? Well, it's going to be the common difference less. So that's going to be L take away D. And the one before that would be L take away 2D. I'm going to use the same trick that I did previously. I'm going to write my sum backwards. So I'd have L plus L minus D plus L minus 2D plus, and so on. All the way up to, I won't do the second to last, I'll do A plus D and plus A. Now, this is where it's interesting again, because if I take these pairs, I notice that again, they always add up to the same thing. And actually, they always add up to A plus L. Because if I look at the second term, I've got A plus D plus L minus D. Well, effectively, the plus D and the minus D cancels out. So again, I've got A plus L. And I've got A plus L because the two D's cancel out. And so I've got all these terms, when they're added together, make A plus L. But again, I've added two series together. So I've got two of my sums. So that means two of my sums must be, well, I don't know how many terms there are. So I'm going to say there's n terms. So I've got n terms multiplied by A plus L, because I've got n lots of A plus L. So the formula for the sum of a series for n terms, so we denote it like this, we say Sn. the sum to n terms. So the sum of my arithmetic series to n terms is given by the formula n over 2 times a plus l. And that's one of the formulas that you can use, and it's actually on the formula booklet as well, that one. But we could write that in a different form, because what happens if we don't know what the last term is, but we know the common difference? Well, if you remember last lesson, we said the last term, un, is given by a plus n minus 1 lots of the difference. So what I can say is Sn is n over 2 a plus, let's substitute this for my last term, a plus n minus 1 times the difference. And so we get the second form of this sum equation, which is the sum of n terms is n over 2 times 2 lots of a, 2 lots of the first term, plus n minus 1 times the difference. And that is also on the formula sheet. So you get both forms on the formula sheet. So these are the two equations that you need to remember. So if we go back, if I'm honest, the three crucial things to remember with arithmetic series and arithmetic sequences is the two different forms for summing and the equation for working out the nth term. They're the three crucial things. Now this is the only one that you're not actually told on the formula booklet, so you do need to make sure that's one that you commit to your memory. Right, so let's have a look at some questions. So find the sum of the series 5 plus 9 plus 13, which has 20 terms. Start exactly as I did last lesson. So I'm going to write what I know. I know the first term is a, the common difference is 4. I know n is 20. So actually, I can use the equation n over, I write Sn. So the sum of n terms is n over 2, 2a plus n minus 1 times the difference. So my sum for the first 20 terms, 20 over 2, 2 times 5 plus n minus 1 is 19 times 4. And it's at this point, use your calculator and you work it out, but just because I can't be bothered typing it in my calculator, I've got 78, so I've got 88, so that's 880. For those of you interested, this actually used to be on year 12 in the old A level that we'd started, that the new A level started about 2 years ago, and it was on the non-calculator paper as well, so you would have had to have done all this without a calculator, but there we go. Now then, look at this one though. So it says find the sum of the series 6 plus 9 plus 12 all the way up to plus 51. So I know A is 6. In this case, I know that my last number is 51. I know the common difference is 3, but I don't know n. And if you think about both of those equations for the sum to n terms, you need to know what n is, because both of them start with n over 2. So that means on a question like this, I have to work out how many terms is in this series. So I have to use my equation un equals a plus n minus 1 d, because I know 51 is my last term, my nth term. So that is 6 plus n minus 1 times 3. Take 6 away from both sides. 3n minus 1, divide by 3, n minus 1, so I get n equals 16. So the first step in this is work out what n is. Then I can do my sum. So my sum, and I'm going to use the a plus l form because it's the simplest one to use. And I know what l is, and I know what a is. So my sum for my 16 terms is 16 over 2, 6 plus 51. 16 over 2 is a, 6 plus 51 is 57. So my sum to 16 terms is going to be 8 times 57, which I can't do in my head, and that is 456. Okay, but just like last time, we can talk about what's the least number of terms needed for the sum of a series to exceed 1,000. And I've accidentally cut off what the series is, so I'm going to make one up. So I'm going to say my series is 5 plus 9 plus 13 plus 17 plus and so on. Okay, so again, my common difference, sorry, my first term is 5, my common difference is 4. N, I don't know, but I want my sum to exceed 1,000. So I can write that like this. I can say I want my sum, my Sn, my sum to n terms, to be bigger than 1,000. So I don't know what the last term is here at all, because I don't know how many terms I'm going to have for a start. So I'm not going to use the equation with the L in. I'm going to use the other form. So I'm going to use Sn equals n over 2, 2a plus n minus 1 times d. And I want this to exceed 1,000. So in effect, I want to say that this has got to be bigger than 1,000. So I've got an inequality to solve. I'm going to put in what I know. So I've got n over 2. 2 times a is 10 plus n minus 1 times 4, and that's got to exceed 1,000. Now, if I'm honest, what I always do at this point is I get rid of this. So I multiply through by 2. So then that gives me n times this bracket is greater than 2,000. And I've got to be honest, I usually do 2 steps at once, because I then also sort this bracket out, and I think I've got 10 plus 4n minus 4, so that is 6 plus 4n. Okay, hope I've not gone too quick. I've done like 2 steps at once there. So expand this out, and I've got 6n plus 4n squared has got to be greater than 2,000. It's a quadratic inequality. So let's get everything on one side of the equation. Minus 2,000 has got to be greater than 0. So effectively now what I need to do for any quadratic inequality is I need to solve. 4n squared plus 6n minus 2,000 equals 0. And this is where you're all really grateful that you've got your calculators, because like I said, this didn't used to be done on a calculator paper, so you had to work it out for yourself. So here we go, I've got 4n squared, 6n and minus 2,000. Pop it in the calculator and you end up with n equals 21.6 or n equals minus 23.1. Now, you can't have a negative number of terms, so that one goes. Okay, now n has to be bigger than 21.6, but n is a number of terms, so then n has to be a whole number. So your actual solution becomes n is 22. So in this sequence I need 22 terms before the sum of this series becomes bigger than 1,000. Okay, but like I say, just use your calculators at these points with your equation solver. Pop it in and just write down what your 2 values are, but it's important you scrub out that n equals a negative. You can't have a negative number of terms. Okay, so then sometimes they stick things together. So they say the sum of the first 12 terms is this and the 8th term is that. So this is where you've got to think about what you know. Well, I know the sum of the first 12 terms is 366. So I'm going to deal with that first. The sum of the first 12, so I'm not going to write Sn, I'm going to write S12. The sum of the first 12 is 366. So I can write 366 is n over 2, where n, but actually I know what n is, so I don't write n over 2, is 12 over 2, 2a plus, well, n minus 1 is 11d. Now, I'm going to tidy this up a little bit, so I'm going to change that, because 12 over 2 is 6. And personally, I'd probably divide through by 6 here, rather than expanding that bracket. So 366 divided by 6 is, let me change my calculator, 366 divided by, I don't know why I'm doing this in my calculator, I should be able to do that. 61 is equal to 2a plus 11d. And then I look at what other bit of information I've got as well, and I've got the 8th term is 38. Well, I can do something with that because I can create an equation with that. So I know the 8th term, U8, is 28. So what's the equation for the nth term? Well, U8 is A plus 9 lots of D. So my 28 is A plus 9 lots of D. And just like we had last lesson, we've got a pair of simultaneous equations. Now I've got 2a plus 11d equals 61 and a plus 9d equals 28. So I'm going to multiply this second one through by 2. 56 equals 2a plus 18d. And then underneath I'm going to write the 61 equals 2a plus 11d. And I'm going to subtract those two equations. 56 take away 61 is going to be minus 5. And 18d take away 11d is 7d. So my d is minus 5/7. Okay. And then if I put that back in, I'm just going to say 61 equals 2a plus 11d. So my 61 is 2a plus 11 lots of minus 5/7. So 61 is 2a minus 55/7. So calculator, 61 plus 55 divided by 7 equals that. Divide it by 2 and we get a equals 241 over 7. And I might have made a mistake somewhere with that lot, but I don't think I have. So, oh yes I have. Right, I'm going to rewind. Where did I make my mistake? Right here. So U8 is not A plus 9a D, 9 lots of D. It is A plus 7 lots of D. Okay, so when I rearrange that, when I double that, I should have got 56 equals 2a plus 14d. So I should have then had minus 5 equals 3d, and so minus 5 over 3 and so on. I'm not going to correct it all, you've got the idea of what to do. Okay, and then the last one, again looking back at what we did last lesson, we're told that the second, third and fourth term is this. So here's my sequence is 3k, 4k plus 5 and 7k. I can use this to work out what my common difference is, because let's be honest, the difference between these is always the same. So I've got 4k plus 5 minus 3k is the difference between those two terms. So that means I've got k plus 5. I've got 7k take away 4k plus 5. So I've got 3k minus 5. So I can say k plus 5 is equal to 3k minus 5, because the common difference has to stay the same because it's an arithmetic series or sequence. And so take away the k, add the 5, and you get 5 equals k. So that means I can write down what my sequence is. I've got a 15, I've got a 25, and I've got a 35. And it continues. Now, I was told that this was the second, the third, and the fourth. So looking at this, I can instantly write what the first is. So I know my A is 5 and my common difference is 10. Okay, so show that. So I've worked out what my sequence is using this bit of information. Now I need to find the sum to n terms and show it is in the form kn squared. So my sum to n terms is going to be n over 2 times 2a plus n minus 1 lots of the difference. Put in what I know. I don't know n. I do know what 2a is. 2 lots of a is 10. plus n minus 1 times the difference, which is 10. Now if I think about expanding this bracket, I'll do this in a different colour, just so above 10 plus 10n minus 10, and you can see the 10's disappear. So I end up with Sn is n over 2 times 10n. So my Sn is 20n squared over 2, which is just 10n squared. Sorry, 5n squared. I'm having a bad day. Is 5n squared, because 5 divided by 2, sorry, 10 divided by 2 is 5. So I showed that my sum is in the form kn squared, where my value k equals 5. Must admit, I don't really like that question because I use the number k to the letter k for different things, which is not very good. Okay, so there we go. Anyway, have a go at these questions. I'll flip it round and show you them again because they're quite wordy. Press pause and then I will show you the answers. Yeah, have a go. Okay, so here's the first one. Fairly straightforward because you're told what n is on the first one. You know what a is, you know what d is. Pop it in the formula. The next two, you've got to work out what that value of n is first, how many terms are in each of those series, and then you can use the formula. I must admit, I went to the equation where you have 2a plus n minus 1d. It's a bit of a habit, but you could have quite easily here said that that was 60 over 2 times a plus l, which is probably the easier way to do it, but there we go. Right, number 2. So find the least number of terms for the sum of the series to exceed 500. So again, you know a is 4, d is 5. You know your Sn wants to be bigger than 500. Use your equation. You should get a quadratic. If you solve the quadratic using your calculator, you got n equals 12.9 and minus 15.5. You can't have a negative number of terms. And so the lowest value is n equals 13. If we look at number 3, this is one where we're going to set up these pair of simultaneous equations using the different bits of information from the question. So it's a bit different, this one, because it said the sum of the second and the sixth term. So that means u2 plus u6 equals 14. But I can write what u2 and u6 are. And so I can add them together and get that 2a plus 6d equals 14. Use the equation for the sum of the terms. And you've got a pair of simultaneous equations. And you should have got a equals 13 and d equals minus 2. And then again, one of these where you've got to set up a pair of simultaneous equations, just the same as before. You told the 15th term, you told the 20th term, so you can work out what d and a are. Then it wants to know what's the value of n if the sum is 2055. It's not saying it exceeds this time, it's just saying it equals that. So you just use your equals sign. And you should be able to do that. And you should have got n equals 60. And the last one, a bit more of a trickier one, but it is feasible that they can ask this sort of question. Again, you're told the terms in terms of algebra. You can work out the common difference. The common difference has to stay the same because it's an arithmetic sequence. So you work out that k is 15, okay? Then it wants you to show that the sum of the first n sequence is a square number. So using your equation for Sn, you can show that Sn equals 9n squared. And the way you show that that's a square number, you could say 9's a square number and n squared is a square number, but the easiest way is to do this, is to say, so Sn equals 3n all squared, and so it's always a square number. Okay, so have a go at the questions that I put on Edmodo, and I'll see you next lesson.